My dear students, welcome to Easy BTech, your guide for BTech and beyond. In this session, we are going to do problems on signal orthogonality, very important for examination. And before going to problems, subscribe, share the channel. It is very helpful to you. Let's see today's session. We are going to see problems on signal orthogonality. So already in the previous session we have seen that, just I am reminding the previous session, we have seen that e power complex exponential functions, e power j m omega naught t, and another one e power j n omega naught t. So these two are orthogonal. Over the interval 0 to t or t naught. Sometimes we can write t naught to t naught plus capital T naught or t, and some other times we can write t naught to t naught plus 2 pi by omega naught. Okay, in all these intervals they are orthogonal over the interval 0 to t naught or small t naught plus t naught, small t naught plus 2 pi by omega naught. These are all the same if you take t naught is equal to 0. All these intervals are equal if you take t naught is 0. So whenever we are going to do problem, this we consider t naught will be 0, then we can proceed. So already it was completed, it was done, and we got the result is 0. Orthogonality we verified 0. This 0 for m is not equal to n. Here m and n are integer values or integers there. So m is an integer, n is an integer, both are not equal. So that is the case we have seen. Now what happens if m is equal to n? If m and same, then what will be the result? That we are going to do now. So here C12 we have calculated. What is C12? Integral T1 to T2, integral T1 to T2. Here x m of t into x star n of t dt divided by integral T1 to T2, integral T1 to T2 x n of t into x star n of t dt. So to check the orthogonality, we consider numerator integral. The numerator integral we consider. If this numerator integral is equal to 0, then the given functions, given set of signals, they are mutually orthogonal over the interval t1 to t2. So if numerator integral is 0, then orthogonal. Then x m of t and x n of t, they are mutually orthogonal over the limits or interval t1 to t2, mutually orthogonal over the limits t1 to t2. And if the given functions are complex signals, they are complex functions given. Now what we are going to see is, for example, if m is equal to n, and this is the case m is not equal to n, they are orthogonal. If m is equal to n, what happens? That we are going to see now. If m is equal to n, what happened to numerator integral? So we know the numerator integral is, what is the numerator integral? Integral t1 to t2 x m of t into xn star of t dt. So here xm of t is, what is the xm of t? E power j m omega naught t, and xn of t is e power j n omega naught t. So here we have star, so xn star of t means complex conjugate of xn of t. So e power plus j will become minus j n omega naught t, right? And here we have limits. What are the limits here? 0, and limit is t naught or t, t naught or t. So here I am taking t. Let's go and substitute and take the condition m is equal to n. If m is equal to n, in the place of m you can take n, or in the place of n you can take m. So I am taking m is equal to n. So that is why the xm of t will become e power jn omega naught t, because m is equal to n. So all this data we are going to substitute in the integral, then we can see what will be the answer. So here lower limit is 0, upper limit is t. Xm of t, what is xm of t? By taking n and m both are equal, it will become jn omega naught t into e power minus jn omega naught t dt, right? Now plus jn omega naught t e power minus jn omega naught t, it will become 1. So 0 to t 1 dt. So it is equal to, what is the answer we get? Capital T. Capital T. So this is the value of this integral if m is equal to n. This is for m is equal to n. If m is not equal to n, if m is not equal to n, the given set of functions e power jm omega naught t, e power jn omega naught t are orthogonal. They are orthogonal over the interval 0 to t, over the interval 0 to t. This is the important point, right? Very, very important, please remember. Now we are going to do another problem. The signal set is like 1 cos omega naught t, cos 2 omega naught t, and so on, sin omega naught t, sin 2 omega naught t, and so on. So he given cos functions, he given sine functions. This total is a signal set. Now we have to go for orthogonality. So prove or show that cos m omega naught t, sin n omega naught t are orthogonal. They are orthogonal over interval or over the time interval, over the interval 0 to t or t naught. So here interval can be, you can mention in problem, sometimes 0 to t he will mention, or he will mention like small t naught plus capital T he will mention, or he will mention like t naught plus 2 pi by omega naught. So all these intervals are same. So whenever you are going to do solution, take this assumption t naught equal to 0 for simplicity. Okay, for simply solving we consider t naught equal to 0 only for simply solving. So how to prove this, how to do solution? So he is asking cos m omega naught t sin n omega naught t are orthogonal over the interval 0 to t. So generally to prove orthogonality, this is the condition. What is the condition is integral t1 to t2 here x1 of t into x2 of t dt is equal to 0. Then x1 and x2 are orthogonal. So here we have cos m, so I am taking here xm of t sin n xn of t. Okay, these are set again, cos omega naught, 2 omega naught, 3 omega naught, here also sin omega naught, sin 2 omega naught. Okay, xm of t into xn of t dt is equal to 0 for m is not equal to n. Here mn integers, there mn are integers, they are integers. So let's see this now. So here xm of t, what is xm of t? Cos function, cos m omega naught t, xn of t sin n omega naught t, right? And the limits here, t1 is 0 and t2 is capital T. So go and substitute and do the integration. Now 0 to t cos m omega naught t sin n omega naught t dt. So if you see this integral, it is like sin a cos b. Suppose if you take it is a, it is b, sin a cos b, or cos a sin b, sin a cos b or cos a sin b product. So this we can write as, in trigonometric we can write as sin a cos b, sin a plus b plus sin a minus b by 2. So sin a plus b, here I am taking this is a and this is b, sin a cos b. So a plus b means n omega naught t plus m omega naught t. We can take n, so omega naught t is common, so you get here a plus b n plus m omega naught t plus a minus b, sin a minus b, so sin n minus m omega naught t. Okay, sin a plus b plus sin a minus b whole divided by 2. So I am writing that by 2 outside, right? Now integration we can do easily. Sin integration minus cos n plus m omega naught t divided by n plus m omega naught and limits 0 to t, right? So here also sin minus cos n minus m omega naught t divided by n minus m omega naught, same limits 0 to t. Close the bracket. This is totally multiplied by 1 by 2. So 1 by 2 as it is. Now we know the relation. So here we go for a substitution of limits, then we go for relation. So upper and lower limits we are going to substitute. So here minus sign Here also minus n we can write outside, so minus 1 by 2. Then here upper limit is capital T, so cos n plus m omega naught t. Here lower limit is 0, so minus cos 0 is 1 divided by n plus m omega naught. So this is the first term, limits substitution, plus here also upper limit is capital T, so n minus m omega naught into t, minus lower limit is 0, that is why cos 0 which is equal to 1, so I am writing this cos 0 is 1 directly, the value 1, cos 0 1, so 1 I am writing, divided by n minus m omega naught, close the bracket. So now we have relation. What is that relation is? Generally omega naught is equal to 2 pi by t. This implies omega naught into t. Here we have product omega naught into t, it will become 2 pi. It will become 2 pi. This 2 pi we are going to place here in the place of omega naught into t. Here 2 pi and here also 2 pi, right? And after that I am talking about n plus m. I told you already n integer, m also integer, then m plus n also will become integer value, right or not? For example, n is equal to 5, m is equal to 3, so 5 plus 3 or 3 plus 5, 8 integer. Similarly n minus m, 5 minus 3 integer. Are you following, right? N minus m is also integer. Now here we have 2 pi and here we have integer value. Again here also integer and here we have 2 pi in the place of omega naught t. So integer in cos 2 pi, here sorry, cos integer into 2 pi. So this total value will become 1. So cos any integer here into 2 pi, which will be 1, right? So this point we are going to take. Then minus 1 by 2. So here 1 minus 1, 0. So 0 by n plus m omega naught, plus here also 1 minus 1, 0. 0 by n minus m omega naught. So 0 by something is 0, 0 by something is 0, finally 0. So we got 0, right? So by this what we can say? By this what we can say? Cos m omega naught t sin n omega naught t, they are orthogonal over the interval 0 to t, 0 to t. For example, cos phi omega naught t, and here m n not equal, that is point, sin 3 omega naught t. Now the integral 0 to t cos phi omega naught t sin 3 omega naught t. So what is the integral value? This integral value 0, right? It is 0, already we proved. So m value is 5, n value is 3, m is not equal to n, so integral value is 0. Now the case is, if m equal to n, what happens? If m is equal to n, what happened to this integral? That is we are talking now. So next take the case if m is equal to n, m and both are equal. What happened to this integral 0 to t cos First I will write original functions m omega naught t sine n omega naught t dt. So what is the case here? M is equal to n. So that point we are going to take sine n omega naught t. M is also n. So cos n omega naught t dt. So it is like sin theta into cos theta, right or not? Theta's same, sin theta here, cos theta here. So we know that in trigonometry sin 2 theta is equal to 2 sin theta cos theta. 2 sin theta cos theta. Now sin theta into cos theta will become sin 2 theta by 2. So let's take that 1 by 2 is outside, 0 to t. What is here? Sin 2 theta. So 2n omega naught t dt. So integration of sin minus cos. So minus 1 by 2 cos 2n omega naught t and divided by here 2n omega naught integration, and the limits is 0 to t. So substitute upper and lower limits. Minus 1 by 2. So the upper limit is 2n omega naught capital T and lower limit is 0, so cos 0, and divided by 2n omega naught. This total is divided by 2n omega naught. Okay. Now think about this omega naught into t product. So omega naught into t is equal to 2 pi, right? Already we have seen this. So take that 2 pi and think about the values. So this will become minus 1 by 2 into 2, 4n omega naught, right? Here cos, this is 2 pi, this value is 2 pi. So 2 pi into 2n, 4n pi, minus cos 0 is 1. That's all. This denominator already we written outside. Okay. And now what is the value of this cos 4n pi? Here n is the integer, any integer. You can take 1, 2, 3, 4, 5 and so on. N is the integer. So what will be the value of 4n pi, cos 4n pi? It is always 1. This value is always 1. So 1 minus 1, 0. Right? 1 minus 1 is 0. So if you take m is equal to n, the functions cos m omega naught t, sin n omega naught t, this integral is again becoming 0. Is becoming 0. So finally, what can I say? This point is the final. Sin n omega naught t, cos m omega naught t are orthogonal, mutually orthogonal, for all m and n. M is equal to n or m is not equal to n. Anyway, they become mutually orthogonal. This is the point. This is the point. Right? So very, very important. And one more thing here I am going to do. I am considering cosine functions like cos m omega naught t, again cos n omega naught t. What this case? Cosine functions. I am taking cosine functions. So check these are orthogonal or not. Over the interval same, 0 to t, over the interval 0 to t. They are orthogonal or not. M is not equal to n, for m is not equal to n. So how to prove it orthogonal or not, how to check it? Same, we consider integral product cos m omega naught t into cos n omega naught t dt. Here limit 0 to t. So it is like cos A cos B. So what is a cos A cos B? It is like cos A cos B. So we can write cos A cos B as cos A plus B cos A plus B plus cos A minus B by 2 cos A cos B. So let's take that cos A plus B cos A minus B by 2. So this will become cos A plus B m plus n omega naught t plus A minus B cos A minus B m minus n omega naught t by 2. So I am writing by 2 outside. So integration 0 to t for both dt and by 2. So now do integration normally. Cos integration sine. So 1 by 2 it is sine m plus n omega naught t. Here also cos integration sine m minus n omega naught t. Limits are 0 to t. So substitute limits now. So here we can write integration. So that is why m plus n omega naught. Here also m minus n omega naught. Integration. Let's take upper limit and lower limit. Limit substitution. So if you substitute upper limit, we get 1 by 2 sine m plus n omega naught into capital T divided by m plus n omega naught plus sine m minus n omega naught capital T divided by m minus n omega naught. Only upper limit I substituted. So whatever lower limit, 0 is the lower limit. So it will become sine 0 is 0. Okay. So 0. So lower limit value is 0. This is lower limit value. Now already we know that omega naught into t is equal to 2 pi. This is the point. Omega naught into t is equal to 2 pi. So then 1 by 2 sine m plus n 2 pi by m plus n omega naught plus sine m minus n 2 pi divided by m minus n omega naught. So what about m n? They are integers. M is a integer, n is a integer. So m plus n also will become integer. M minus n also integer, right? So here integer into 2 pi. For example, take 2, integer is 2. 2 into 2 pi is sine 4 pi. Here for example 1 into 2 pi sine 2 pi. So sine 4 pi, here sine pi. So sine n pi is equal to 0. This is the point. Sine pi 0, sine 2 pi 0, sine 3 pi 0, sine n pi is 0. So that is the case here now. Right? So here it is 0. The first term, second term also 0. 0 plus 0 and 1 by 2. The answer is 0. Answer is 0. M is not equal to n. So what is the clarity? Final. Functions cos m omega naught t, the same cos function, cos n omega naught t, they are orthogonal, over the interval 0 to t, m is not equal to n. For example, if m is equal to n, what happens? If m is n, so in the place of m we can take n, or in the place of n we can take, so I am taking now m is equal to n, so then integral 0 to t, so here cos, I am taking m is n, so cos n omega naught t into cos n omega naught t dt, this integral I am doing, so cos theta cos square theta, then 0 to t cos square n omega naught t dt. So cos square theta we can write as 1 plus cos 2 theta by 2, then 1 plus cos 2n omega naught t by 2 integral 0 to t dt. Let's do this integral. Here 1 by 2 we can write outside. So integration of 1 is t plus cos integration sin 2n omega naught t divided by 2n omega naught. Here limits are 0 to t. Let's substitute that limits, upper limit and lower limit. Upper limit is t plus sin 2n omega naught into t divided by 2n omega naught, and lower limit is 0, so here 0, here sin 0 also 0, so lower limit value is 0. This will become now sin 2, already we know omega naught into t is equal to 2 pi, then it will become the value of sin function, sin 2n into 2 pi, n is the integer, right, n is the integer value, then 2n into 2 pi, sin 4n pi, and n is again integer, so total value is 0, so this is 0. Then answer is, what remains? T by 2, this is the answer. So if m equal to n, this integral is t by 2, okay. And similarly sine functions, if you take sin m omega naught t, sin n omega naught t, same, they are orthogonal over the interval 0 to t for m is not equal to n, mn not equal, then they are orthogonal. Suppose if m is equal to n, we get again t by 2, right? Very important, all these. So finally I will give you conclusion or summary. What is the first thing is e power j m omega naught t, e power j n omega naught t, these are orthogonal over the interval 0 to 2 pi, 0 to t, so interval is common for all, 0 to t, they are orthogonal, m is not equal to n, right? If m is equal to n, what happens? If m is equal to n, what is the answer? We get t, right? We get the answer t. That t I am writing with e power mn equal, then we get the answer t. So that is e power j omega naught t into e to the power, these are complex functions, so minus j n omega naught t dt. This total integral is t if m is equal to n. And the second thing, sin cos functions, sin m omega naught t, sin n omega naught t they are orthogonal. Orthogonal means integral value 0 to t sine m omega naught t into sine n omega naught t dt is equal to 0 if m is not equal to n. If m is equal to n, what happens? We get t by 2 if m is n. Similarly, cos function, cos m omega naught t cos n omega naught t and integral 0 to t cos m omega naught t into cos n omega naught t. This integral value will become 0 if m is not equal to n. If m is equal to n, it will be t by 2. And last one, fourth one, sine and cos, like sine m omega naught t cos n omega naught t. So these two, 0 to t sine m omega naught t cos n omega naught t dt is equal to 0 for all m and n. This is the point. Means m is equal to n, m is not equal to n, the result, integral result is 0 always. So this is very, very important for you. Okay, so I hope I am very clear to you. So this is the session today. I am stopping here. So we have next session, Fourier series and Fourier transform. Okay, students, share, watch videos. Thank you all.